Okay, so this is going to be part 2. Miss Lauren is here to help me, and let's review what we have, because Miss Lauren had a question. How did you go from 331 to 2? Excellent question. So let's just review what we did. We had a complete balanced formula equation. This type of equation is called a
stoichiometric equation.
Okay, that's the first thing in the study of stoichiometry. It's pronunciation. Okay, stoichiometric equation. Say that.
Stoichiometric equation.
Excellent. Stoichiometric equation. The study of stoichiometric equations is stoichiometry. Say it, stoichiometry.
Stoichiometry.
Okay, good. So, the mass of 1 mole, we're going to look at this as 1 particle, 2 particles, 1 particle, 2 particle, or 1 dozen, 2 dozen, 1 dozen, 2 dozen, or 1,000, 2,000, 1,000, 2,000, or 1 billion, 2 billion, 1 billion, 2 billion, or a mole, 2 moles, a mole, 2 moles. Okay? The mass in grams of 1 mole of any particle is equivalent to the mass of 1 particle in atomic mass units. So the mass of 1 mole of this particle is 331 grams. The mass of 2 moles of this particle is 300 grams. The mass of 1 mole of this particle is 461 grams. The mass of 2 moles of this particle is 170 grams. Are you okay with that, Lauren?
Yep.
Excellent. So,
but
yes.
Like the mass of 1 mole of lead is 207 grams. So how do we get all that down to 2 grams without losing all of the?
Okay, we're going to do that. Okay. So, do you understand this so far?
Yeah.
Do you understand that this is the stoichiometric equation, and these are called the stoichiometric masses?
Yeah.
The reason I put this number up here was just to show you the law of conservation of mass. The law of conservation of mass. You have 331 plus 300 is 631. 461 plus 170 is 631. Okay? But these are stoichiometric masses. So all I'm asking you right now is, do you understand this?
Yep.
Okay, good. Now, what we're going to do is we're going to go to a bottle, a reagent bottle, where I have lead 2 nitrate, and it's a bottle. It says lead 2 nitrate. Okay? And I'm going to take out 2 grams. Right? And in that 2 grams, I'm going to have lead 2 nitrate. So I'm going to take 2 grams of lead 2 nitrate. If I wanted a whole mole of lead 2 nitrate, I would take out 331 grams, right?
Yeah.
But I don't want 331 grams. I just want 2 grams. That's all it is. I'm just taking that much chemical out, okay? If I use 331 grams, I need 300 grams. But I'm only using 2 grams. So how many grams of this am I going to need? So you're going to need your calculator. So in other words, I'm going to say, this is going to be my ratio, my constant ratio. Remember, stoichiometry is the study of the constant ratios in a stoichiometric relationship, which is in the form of a stoichiometric equation, right? Okay, so lead 2 nitrate, so I'm going to write it like that, over 2 sodium iodide is 331. I'll leave off the grams just for ease of, just for visual, over 300 equals 2 over x. So what's x?
X is 300 divided by 165.5.
Cross multiply and divide, girl.
Oh.
300 times that is 600 divided by 331.
Okay. 600.
600 divided by 331.
1.81268888.
All right, give me 3. When in doubt, 3 significant figures. 1.81.
Okay.
Okay, when in doubt, 3 significant figures. If you want to go crazy, if you want to live on the edge, 4 significant figures. If you want to hear a knock on the door and be arrested by the significant figure police, put 5 or 6. Then you'll hear that knock on the door in the middle of the night. Open up! This is a significant figure police! And you'll get arrested. Okay? Don't let that happen. Okay. So that's correct, right? Now, let's put down the next ratio, okay? And we'll say lead 2 nitrate over,
But you forgot the little 2 there.
thank you, nice assist, excellent.
Thank you.
So lead iodide equals
461 over
461, right?
Yeah.
Excellent. Equals what?
461
Right, 2 over y.
2.9. 2.79.
2.79. Okay, you get it? So 461 times 2 divided by 331 is 2.79, right? 3 significant figures is fine. Yes? Okay. Now, according to the data, you should only have 1 significant figure. Did you know that? Don't worry about it. Because you only have, I only wrote that as 1 significant figure. But don't worry about it. You will for chapter 11, but not right now. Now, let's do the last one, okay, which is right here. So we're going to say lead nitrate over what's that noise? Lead nitrate. I got spooked by that noise. What was that noise?
I don't know. It sounded sort of like someone's phone. It wasn't my phone. My phone's on silent. But you needed 2.
Sodium.
2.
Oh, the 2 here? Sorry. I did get rattled by that noise. What was that noise? Like the walls or something. Okay, equals what?
Wait, sorry. 1, 2.
Equals 331 over.
1.03.
Is this on the thing?
Yeah.
Is this on?
Yeah.
331 over what? 2 over z, right?
Yeah.
That's all on there?
Yeah.
Okay. Z equals what?
1.03.
Okay. 1.0. And that makes sense. About half. Yeah. Okay. And that's it. That is it. Okay? That is stoichiometry part 2, but that's it. That's all it is. It's nothing else. Do you know what this is called? Do you know what this is called? This is called type of calculation it's called. What is the type of stoichiometric calculation? What is this called?
Algebra?
Algebra. Excellent. Algebra is the tool that we use to solve the problem, but the class of calculations.
Oh, calculus?
No. Oh, God, no. No. I didn't want to tell you before. I wanted you to figure it out. And we only have a couple of minutes left because I have a meeting at 10. Okay? But it's going to be, I give a mass and I have to calculate another mass. So it's going to be what type of calculation? It's going to be, believe it or not, it's called
mass stoichiometric calculation.
Yes, that's a mouthful, isn't it? Is that all on the video?
Yeah, the little red thing is still flashing, so it's recording.
Good, excellent. Mass stoichiometric calculation. Cool or what?
Why do you need to repeat mass twice?
Because you're given a mass and you're solving for a mass.
Yeah, but you've already got the masses. You're just working with the mass. You don't need to go.
Well, it's going from mass to mass, and I'm going to tell you why. Because you have volume, mass, volume, and volume, mass. You have 4 types of calculations. That's the first one. And part of this chapter, this is easy, it's straightforward. What's the hard part about the chapter? A lot of this might be even on your own. Sorry. You have to know how to do this. In other words, you have to know that this is a double replacement. That this is going to be, you can write this down as literally, let me use black, This is an A. This is B. This is A. This is B. This is A, D, C, B. You gotta mix them up. This is lead 2 nitrate. So that's gonna have a +2 charge in there, right? This nitrate is a -1 charge. Remember the charges with atomic theory? This is +1, sodium, right? Group 1. This is halogen, group 17. These are -1. This is going to be +2, because it's +2 over here, right? This is going to be -1, +1, -1. So I need 2 of these over here, because you have -1 and +2. You have 1 of each here. You don't need this 2 to go along with this. You have to settle these these formulas individually by themselves, and then see how it all falls together in an equation. Speak loudly.
Wouldn't the mass be impacted by the change from atoms to
No,
ions?
because the mass of an ion, the mass of a lead atom is the same as the mass of the lead ion. It's just two electron difference.
Yeah.
But it's picking up electrons, but it's not going to make a difference.
Yeah.
Because the mass of the electrons are, as long as you're not losing protons. Right? So +2, so that's why you have the 2 there. That's why you have the 2 there. That's why you don't have any subscripts, etc. See? You've got to know that. And we'll go over that again as well. We have to do a little equation writing with this unit. Mm-hmm. It expects a lot. There is no high level with stoichiometry. It's all standard. There is no high level. It's all the same.
So we're going to do this after we get back from Water Festival?
No, Water Festival is the final exam after that. Then we're going to do the stoichiometric as a paper, as a separate unit after exams.
Oh, okay.
Hopefully before the vacation. Otherwise, it'll be awful. Okay? Are you okay with that?
Yep.
Okay. End of Stoichiometry Part 2. Thank you, Lauren, for the help. Excellent. She was my audience. Couldn't have done it without her. Interactive, and goodbye.